let us know when it's done.
So it's live on YouTube.
Where's the camera coming in from? Oh,
Yeah.
okay.
Yeah, it's live.
So,
Yeah. Hi everyone, in the room IRL and also online, joining us on YouTube and also via Zoom, interacting with us. If you are watching on YouTube and you want to get in on the action with this V4 meetup and interact and get to know everybody, there is a Zoom link on the vvvv website, the visualprogramming.net website, so you can go there and join the Zoom link if you're watching this from YouTube and would like to interact while eating popcorn. So for those of you who don't know me, my name is Harshini. I'm the program manager for the Node Institute. So I'm here just to help facilitate the courses and also get to know everybody. So I'm always so amazed by what the V4 community is creating. So if you're on any type of social media or if you want to share what you're doing, please do that with us. We're more than happy to share all of your work. This season is the summer season at the Node Institute, so we launched our V4 Beginners course again with Christoph and Rosie, which kickstarted this week. Yeah, this week. And also our intermediates class, which started yesterday with Randall Vasquez. So anyone who's watching online that wants to join, you can still sign up for both of these classes. And yeah, we have so many people that are presenting projects and things today, and I'm really excited to see. I'm going to be bouncing today a little bit for those in the room because we have another event, another class running at the same time. So I'll be in and out, but still will be following along. So maybe I leave it to David or Yorick to introduce our speakers.
Thank you, Harshini.
Yeah,
okay, great to have you all. I don't know how many people are watching the stream, neither do I know how many people are with us on Zoom exactly, but nevertheless, we are like 1, 2, 3, 4, 5, 6, 7, 8, 9, including me, it's 10 people here in Berlin in the space. And I think we're gonna have 4 to 5 presentations. We have Chris Engler, Wir machen bunt here in Berlin. He came all the way from Hamburg. I think for those who are long-term vvvv users, this name is well known. He's gonna presenting, honestly, I don't know what, but it doesn't really matter. It's gonna be exciting for sure. Then we have online with us Christoph Kiermeier and maybe Rosie as well. Yes, I see her face there in a little box. That's great. Hi, Rosie. Good to have you. Then we have Tebian Halm, who recently made some noise about a Python integration and stable diffusion integration to vvvv, and he's going to present that. And who else is then? Johannes Schmidt, Kopffarben, presenting some ImGUI magic, as I would now call it. Well, he's gonna shed some light on this. And M4D, that's super great to have you here. You're gonna present what?
I have my modular synthesizer in the back, and I could improvise a little. Just
Okay.
if we have time left,
that is
and
great.
if people are interested, I can show the real patching. So.
Okay, let me get the equipment in the back office, and we'll prepare that for the
After party.
For the after party, exactly. So yeah, so first would be Chris Engler. That's great. Okay, is everything set up there with the microphone and camera?
Yeah.
Great. Okay, then.
I share my screen. Let me. And play. I'm still seeing the Zoom stuff. I do. I can't get rid of that. Anyway, I was wondering how I start this presentation. I'm Chris Engler, and I wasn't sure what kind of audience we have. The Node Meetup, is this just insiders, or do we have like new people online? I don't know, so I just start as if nobody knows me. I'm Chris. I'm teaching at the Malteser Kunsthochschule creative coding. I also run design studio in Hamburg, which is called Wir machen bunt. And I started off doing these kind of things by studying actually music and composition. So I'm actually a musician, but while studying this kind of stuff, I discovered Max MSP and Jitter and Nato, and then slowly discovered vvvv and switched over from making music to doing visuals and programming. And yeah, I think in 2004 I discovered vvvv. And with the help of Urek, I searched the forum for one of my very first threads in the forum, and this is actually the second one. I was asking how to stop zip patches, and to be fair or to be honest, I think the if region solved actually this problem, so it didn't take too long to fix that problem. So I'm really glad that this is working. No. I mean, it's like 20 years on now. It's crazy. Anyway, again, a little bit of self-promotion regarding Wir machen bunt. Wir machen bunt, as I said, is like a studio. We create like interactive exhibits and immersive shows, XR apps, and work with Unity, Cable3L, so all sorts of tools, do animation. And if you are interested in this kind of stuff, check out the website. And maybe you are interested enough and you want to apply for an internship, either design-based or creative coding-based. It's up to you. And apart from that, I said I'm teaching at the Muthesis Kunsthochschule in Kiel. And there's some echo. Jurek is trying to sabotage me in the background. Yeah, Muthesis Kunsthochschule is basically a design academy where you can study like interactive media design, industrial design, communication design, architecture, but we also like work a lot with AI, XR, data visualization, science communication. So if you want to study this kind of stuff and you are interested in a small, cozy academy and you love fresh sea air, so maybe you apply there as well. So that was the self-promotion part. And now let's go to the project I'm going to present. This is called Iconic, which is an immersive interactive show currently running here in Berlin, unter den Linden in the VW forum. It's, yeah, as I said, interactive, immersive, lots of projectors, interactive walls. Let's see what the next slide shows. Yeah, next slide is a video, so maybe it makes it more visually understandable what this kind of installation is. So it's quite a vast space. Each of the wall is touchable, and it's, of course, it's like it's sponsored by VW, a car manufacturer. But fortunately, it's not really about selling cars inside the immersive space. It's more like a emotional experience, like a journey through time. And this space is also connected to an exhibition which is in front of that space, which is about iconic design in the product world, I would say. Like if you look at the Artemis lamp, you find it there, and some other like product design iconic things. Yeah. So this is why this whole installation or the whole project is called Iconic. It explains itself when you see the exhibition outside of that space. So how does this installation work, and what kind of challenges did we face? Jump a little bit further. This is the exhibition space. It's projected by 9 4K projectors using wobble upscale. who has heard me about wobble upscale? Not many here. So basically, wobble upscale is you feed in a 4K signal into the projector, but the projector itself is actually a full HD projector, and it's moving the 4K image quadrant by quadrant really fast and picks up the 4 quadrants really fast by 240 hertz, and therefore is able with a full HD chip to show a 4K signal. It does basically really quick and scans the 4K image. Yeah, it's actually visible. If you know it and you look at the projection, you see it's flickering a little bit, but it's 4K, which is nice.
You feed a 4K at 60 hertz.
Yeah, and the projector internally runs I think 240 hertz and moves the 4K image really fast, or scans the 4K image really fast with a full HD chip.
Someone proposes this, and you would say it's a bad idea, no? Let's not try it.
It's working. It's working. It's working.
Is it doing it like this or like Italy?
I'm not really sure. You have to look it up. I know. I only know it's like 4K in, and it's actually only full HD but fast moving. Yeah, which is
it's cheaper to manufacture. Like
it's definitely cheaper. Yeah, it's cheaper than a real 4K projector. And when you look at these kind of sizes in terms of projection, you need like a lot of light and not a lot of quality in terms of light. And it's definitely it's more achievable with this kind of technology to get this kind of projection. We have 9 LiDAR sensors. These are the pink ones. I tried to visualize here. Anyone knows what a LiDAR sensor is or doesn't? Most of the people here. Just explain it anyway. It's basically a fast-moving laser beam, and it measures the distance between the sensor and the surface the laser beam is targeting. And if the laser beam actually hits a hand or a finger and measures the distance to that hand or finger, then you basically know where the hand or the finger is, and that's basically the technique to make this whole surface like touchable, like turning this whole surface into a big touch screen. Yeah, and there's obviously there's a bit of mapping and merging of sensors in the erforderlich. Anyway, what else? 16 channel surround sound. There we have spatial sound. Like when you touch the surface at a certain place in the space, you definitely want to come sound from that position. So you need a lot of speakers, and therefore 16 channel surround sound. We play back the whole stuff with 2 vvvv media servers, not Touch Designer, not Notch or anything. It's vvvv. We have a pip mode for like presentation stuff, configurator tool. LaserBoy is actually our software running the merging of the LiDAR sensor. And we have 2.5 terabytes of video content playing back in 12 minutes. That's quite a lot. Anyway, technical details. In terms of content, the content of the show, as I said, is like 12 minutes. We have split into intro, future cast, future cities, future tech, and outro. The 3 chapters in the middle have interactive parts, or basically they are fully interactive. But I have to say each scene is split into or built up in a certain way. So we have basically always a video layer as a background, which is done by Flora Fauna Visions. And we put our interactive stuff on top of it. And this is also combined with spatial sound done by not Ku Klux Klan, it's Kling Klang Klong. Yeah, that's basically the credits as well, like Flora Fauna Visions Berlin, Kling Klang Klong Berlin, and Wir machen Bund Hamburg. Basically, the guys who did this. Let's have a deep dive in terms of how the scenes are done. What was new for us that we actually did all the scenes with views and with shaders. There was no object-oriented programming or classes or stuff like that, or C# or anything. It was just basically only shader stuff this time, which was really fun. That's because we call it a shameless shader show. Fuse. There's a lot of Fuse stuff going on. And yeah, let's dive into the Fuse stuff, how we did the things. First of all, we had, first scene is future cars. Unfortunately, since this scene came last, it's basically just introduced for a couple of weeks ago, and I didn't have the chance to actually film it in the space, so I have only this kind of video. The car scene you see is pre-rendered in Unreal Engine, as far as I know. And we put this particle layer on top of it, which reacts either to the cars and to touch input. It's quite subtle effect, but it's the particle layer definitely gives the impression that it actually works together with the video. So how was this made? Quite a complex compositing in the background. At the top, we have a pre-rendered depth map video, which is also coming from Unreal Engine, which gave us the ability to extract or to know where the cars are, and also like people walking by and buildings and stuff. And by filtering, like for example, the cars, we could then put the cars into a optical flow path and check out which kind of direction the cars are driving, which then later on was fed into the particle system and controlled the flow of particles. So each time a car or a drone drove or flew by, it was actually manipulating the real-time particles. On top of that, we have always had this kind of like drawing layer, which is the layer where the audience can, like when they touch, they draw into that layer, which, let's play that back, is also like fed into the optical flow, which as well controls the particles. If you guys here in Berlin have any questions, like interrupt me.
What is the second layer?
That's basically the filtering layer where we like filtered out the cars. It's unfortunately not put into linear mode. It's like this kind of representation is rubbish right now. But you have to imagine that this is basically the layer just showing the cars. Yeah, that was quite fun to work out. But to be honest, really subtle effect when you like in the space, like these kind of little tiny white lines. It's like so much, lot of technology behind it, but
Is the full resolution going 360?
it's 270.
What's the resolution? So it's 9 times 4K.
Full resolution, like we had to play back everything basically.
So it's playback the depth video and the color.
Yeah, although I have to say the depth video is obviously like low resolution. It's enough for this kind of stuff. The only full resolution is basically the video layer.
But why do the cars pop out that much on the depth video? Are they treated special like in the Unreal rendering?
Good question. I just possibly. I wasn't involved in the creating the depth map video, so we just ordered it. Basically, we need the depth map video, and then this came. Sorry? No, it's all DDS.
A single frame.
Yeah. 50 frames per second. Like really large DDS files.
Was there a reason to use DDS and not PAL?
Basically, we play back 8 of the projectors with basically with just one machine, and this is the only setup we got working that way. I mean, you can play back this kind of space with multiple machines, obviously, but we wanted the challenge to play as many projectors just with one single machine. It's basically the setup which works that way, but it's right on the edge of what's possible. The second scene is called Future Cities, which is my favorite actually because conceptually it's showing like AI renderings of future architecture, which you've probably seen here. So it's the combination of the video layer shows like AI generated architecture, which is like morphing from one architecture into the other. What I like about this scene is like these kind of two-dimensional shapes give the AI rendering a certain structure, and so it's not like dreamy AI stuff. It has order, it has structure, it has really architecture. And I quite like this kind of concept, having a little bit of more control over the AI rendered stuff. In terms of the real-time layer, almost there. Okay. The real-time layer is consisting of these kind of spines, obviously, and a particle system, which reacts on touch input. The idea is you can charge up each shape, which is then collected in the middle, charging up a center particle system. What I found really interesting was, first of all, like solving the problem of these animated spines, which is really just meshes and with certain coordinates. But the most interesting part for me, or where I learned the most, was I do this kind of particles stuff with just one particle system, which is really performant, rather than having like, see this picture, rather than having like 28 emitters and 28 forces. I do this kind of shit just with one emitter and one force, using the group ID, or it's basically called group ID. It's like a special shader attribute, which Chris Enrico showed me. So I can basically assign a specific information to each particle, which tells me later this particle belongs to the first emitter or the first shape, and the second particle belongs to the second shape, and stuff like that. So I basically tag each particle to later know where the particle is actually coming from, to be able to magnify and move the particle in a certain way. So they're not all moving towards the central center of the scene, but they have their own center and their own target force and stuff like that. Yeah, and that turned out to be really performant. So I could really mess around a lot and learn Fuse a bit better. What else? I created my own rotational force in Fuse, which didn't exist so far. Also a learning curve. So is this possible? What kind of math do I need? Okay, that's not so complicated, and it's because Fuse is so modular and so low level, I was able to do it myself and just don't have to wait for any release or stuff like that. I can create my own rotational force, which I really liked. Any questions concerning this?
And when was the project? How long did it take you to complete?
To be honest, from concept to first release, 4 weeks. Yeah, that was tough.
And how many people worked on it?
2.
So on your
On the interactive side, yeah.
And how much of of a style frame was given, what you have to achieve visually on it?
It was pretty accurate to what we see, you know. There wasn't
brief was visually super clear.
Yeah, there wasn't much experimentation on our side. We could decide in terms of like amount of particles and how they move and so on. We didn't get any animated stuff, but like still images, and went from there. Did the motion design.
And you learned fuse on the way.
Yeah, pretty much. Yeah, I had a little bit of user experience beforehand, but I learned the most in that project. But I mean, I'm doing this kind of shit like since 2004 and did shader stuff before, so it's not a big leap. Yeah, I did shaders before. I'm almost finished. The third scene is called Future Tech. Here the challenge was basically creating a lot of buttons. Big button wall. So the first idea was obviously, okay, we make a class and like rectangle and point within rectangle and stuff like that. So it's a view length button, but in terms of this kind of amount of buttons we needed, it was like purely not possible. So we had to do like GPU buttons. I'm gonna quickly tell you how these GPU buttons are made. Let's see them in action. It's like a big pixel, interactive pixel wall with sprite sheets, rectangles or sprite sheet buttons, and noise animation and video analysis also in the background. Anyway, so how's it done? What I first made is in Blender a grid of rectangles, which I assigned 2 UVs per rectangle. Each rectangle, so the first UV per rectangle was scaled down to 0 and positioned within the UV map, which you see on the left side. Like each rectangle is basically pointing to a certain position in the control texture, but only just a really tiny amount, just pointing at a single pixel basically. The second UV per rectangle is shared across all rectangles, which is later used for the sprite sheet. So it's like taking the whole UV canvas for each rectangle. And the idea was like, okay, we have the control texture, like you see here, the noise texture under UV, and we pick up the brightness of the pixel and turn this brightness of the pixel into the transformation of the sprite sheet on the right side. So we can control the sprite sheet by the brightness of the pixel on the left side. So giving us the control to change the look and the appearance of each rectangle or each button by this control texture, which is like really performant and actually the grid or the mesh you see of the rectangle is just basically one mesh, not even an instance or anything. It's just one big mesh. So really easy for the GPU to do this kind of stuff. Here you see the combination, like at the bottom you see the noise control texture doing like all this kind of noise animation on the sprite sheets, and at the top you see again this kind of drawing there where people would interact with the wall and draw this kind of white and black and white control texture, which then later on again was turned into control values to control the sprite sheet of the buttons, which, let's go back, looks in the end like this. Yeah, we spent quite a lot of money for like really for the most expensive graphics cards for this kind of project. It turned out in the end wasn't necessary. It was so performant in the end we could have taken like really lower spec graphic cards for this. Which is
for this one or
for this one?
for the whole project?
Yeah, for this one.
And this one.
But most of the scenes run on a Quadro 4500, which is like really low spec, narrow card, which is not much power. Oh, one last thing, and then I'm finished. last but not least, our dirty syncing audio secret. We lost frames. And don't know why and don't know how. It's not visible. You should see the show. There's no jumping, nothing, but we lose frames somehow. When we count the frames, they are gone. So the problem is when you play back like a 12 minutes audio file and you're losing frames, at some point your visuals are out of sync with the audio, which is like a bad thing and adds up a lot. So we thought about how can we bring the audio back to the image, and I just tried. It's really, really dirty. I changed when we have an offset between like the frame count of the audio and the visuals. I slowly, gradually turned on the speed of the audio, which is like really dirty and it should be noticeable in terms of pitch. But I do it like really, really tiny amount, and you don't hear it, and it works. Which is like, it was really like a Eureka moment.
Just
so, sorry.
If I may come with a note, I've dealt with that kind of problems by calculating how much the audio is out of sync within each loop, and then use a stopwatch to replay from start, so that it's basically being synced whenever the audio restarts.
But in our case, we have only one start at the beginning of the show, and then it plays for 12 minutes.
Okay, yeah, but it's plays for 12 minutes?
12 minutes, yeah.
But does it drift? How many frames do you lose?
Enough. I don't know. It's like half, after 6 minutes, it's noticeable. So,
okay.
For us, it wasn't also noticeable for the rest of the guys at the site, but for us it wasn't also noticeable, so we tried to solve that. Yeah, it's real audio. I tried Ableton. Maybe next time I use Ableton for the audio playback to sync. I've tried the Ableton link, which I find really amazing, which works like out of the box. And maybe next time I use Ableton for that kind of stuff. But now I want to thank definitely Christian Wieker for the continued support throughout the projects. Björn Schwarzer definitely, because I think vvvv Gamma is not usable without the add-ons, to be fair. And obviously Jurek and the vvvv group for the mothership, because this kind of special installation in terms of like special software we write for running this kind of shit only on one machine. It's only possible with vvvv. So, yeah,
Thank you, Chris. Is there any questions from anybody online or on site that we need to solve right now? Any comments somewhere? Well, then
Just cheers and
cheers and great. And I think it's really good to see like these real world professional use cases quite in-depth explained, and I think we as a community need those kind of narratives a lot to tell the stories what's possible and how brilliant vvvv shines when it gets to really complex scenarios. Yeah, saying that, thank you for your insights. And then maybe we just shift over to the next use case with Rosi Grillmeier and Christoph Kiermeier, who are also
Myers.
Project.
Yes, the Myers. Hello, everyone. Thanks for having us today. I'm Christoph, and today I'm here together with Rosi. Normally, we've been working together the past 2 years on the beginners course on the Nord Institute, but today we're representing the Studio 3E8, which I founded together with my friend Felix in Berlin last August. And yeah, the backstory about the projects that we're showing today, we're showing two projects, one light installation and one interactive installation for Klimabiennale in Vienna, is that we have received funding from Vienna Business Agency, I think last October, November or something like that, which made it able for us to work together as a team of 6 people on toolkits for interactive installations, multimedia installations, and we're all developing this on the base on VL and vvvv. So basically, we're developing little modules that enable us to do our projects for museums, trade fairs. You all know where this goes. And yeah, these modules are, for example, a multi-touch framework, a library for sound and light design, data visualization tools, a content management system. What else is in there? Yeah, basic workflows, stuff like that. So things that make the work easier and that you can really pull out of your toolkit every time you do a project. But what's also nice is that this funding enabled us to develop these toolkits not without a project or just naked and then just show them to customers and without any use case. It was possible to develop like 4 to 5 own productions based on these toolkits for our portfolio, basically, and which is nice because we could basically do whatever we want with these technologies. And yeah, the first installation I would like to show is just a second. Give me a second to share the screen before I hand over to Rosie. Is a light installation we're doing for a festival called Lucid Dreams in St. Pölten. It's a little town nearby Vienna. I also teach there before since 3 years together with Matthias Hosinski. And this year I'm doing also some courses in this Master for Experimental Media, and together with the students where they're developing this festival digital art Lucid Dreams. And what we basically do there is we're doing a light installation on top of this main entrance of the Bühne im Hof. It's this theater in St. Pölten. And yeah, basically, this is going to be the structure. We're waiting for the parts. They're being delivered right now. We're eager to start soldering and programming this thing and yeah, make this, install it above there. And yeah, as I said, we're 6 people. These are 2 of them. This is Felix. This is Elena, and they are basically working on the light installation right now. And 4 other people, and I will stop sharing my screen now. 4 other people, Rosie and also Thomas and Ben and me, we're working on this project for Klimabiennale. And this is where I would hand over to Rosie before I go over to the other screen and make a presentation on the table. Thank you very much. Yeah.
Hello. You hear me?
Yes.
Yes, cool. Good. Yeah, I'm one part of the team involved in the development of the data visualization and one of the projects right now. And it's a project, as Christoph already mentioned, together with the Klimabiennale in Vienna, which is happening for the first time. And it's an event for 100 days that is between art and activism from the Wiener Festwochen. And there I realized that usually I'm there because I'm also part of the climate movement and I'm in different organizations there. And one of the places there will be an activist camp where all these organizations can go and share their knowledge and do campaign planning, exchange with visitors, and do science communication and what's so on, and action planning. And now I share my screen. Yeah, and thanks to the campaign office Radius, I got an overview here of only in Austria how many civil action movements are there in just in climate and social activists. Sometimes people hear about Fridays for Future or Letzte Generation and so on, but it's much bigger. And all of them are somehow connected with each other because they have this or the other campaign together. And all of them will gather here at this Klima activism camp if they're in Vienna. And there will be a lot of workshops and a lot of stuff happening. And in January, I thought when we knew we had this funding, that we could do a visualization that is kind of showing how all of this works together and make a very lively map of the city of Vienna and also mark places in Austria. And I want to reference a project here by Schnelle Bunte Bilder that that inspired me for how this could look like. It's let long and it's on their website. It's in this case, it was a visualization of San Francisco, and I was then imagining how a city could get alive if you start showing what's happening in this city. And I did a little test when I was there the last time in Vienna, where I just hung up a map of Vienna. There were like people from 20 different organizations, and we asked them, which places do you like, which do you don't like, which do you have good memories, where do you have bad memories, which places you want to change, or which places you or an organization you're part of changed, so forth. And so we got a little input of how the data could look like. And from that on, we started thinking, okay, how could we visualize that? And a friend of mine from Ars Electronica, Klaus Dietersdorfer, once made a very interesting visualization as well, called the map of perception, where they also with OpenStreetMaps mapped where people like to be, where they don't like to be. And I thought if we had a public exhibit, we could have people engage with stories about places and how they would like to change places or which kind of change they would like to see. So all of this is just like how all of this came together. And then one nice morning, opening element, there was this amazing picture in the Fuse group about how you could use a city as a height map for SDFs in Fuse and then spawn particles there. And so we got into this direction of having emissions where people are gathering, having with the background information of what organization are they part of, which places they like, what do they want to change and what not. So all of this is in development right now. And the project will start on 17th of May in Vienna, in case you are there. And it will be presented on a multi-touch table by Interactivescapes. And if I still have time, I would like to show you how what patches we are doing right now. We got some input by Brian Moll and Vincent Novak about the city visualization. So if that's fine, I would like to show the state of the project.
Yeah, go ahead.
Nice. Okay. Okay, cool. So there we are in vvvv land. This is one of the things I already showed. It's just how to make emissions inside of a collision. And then the idea of showing that on a city map. So that was one of the first patches. And then the next one we had was just using one tile from QGIS. Don't know if you know what QGIS is. I just got, like, the last 2 weeks were amazing because I could learn how to use this. You get, for example, a data set of everything in Vienna, the height of all the buildings, for example, where there are public spaces and whatnot. And you can then create a topography, and you can also classify the buildings by height. Just because I thought it was super cool. These green little dots are Hundekotzackerlspender in Vienna. Like, even that, you can know exactly where they are. So Vienna is one of the best documented cities for open data, which helped us with this because we could get the height of every single building. You could also get places. You can get places of anything. You can get pretty lost in this. You can see places where you should get married and where you should not get married, and then where you can learn to drive and where you can get the COVID test and whatnot. And yeah, so that's all in here.
Who's maintaining that data sets?
The Vienna dataset is by the MA41 City of Vienna. They are doing public data and then giving it to the QGIS or community. So I had to just connect the API URL to QGIS, and then I got all this data from Vienna. Which was cool, very cool. And from that, we did like one little tile, which is just for now. Where are you? Here. This is just like one part of it. And then we try to see how can we make Fuse work on all of them. And therefore, Christoph did this cool patch, which is showing, like, if you have a part of a texture, yeah, you can see how much, depending on what you're doing with the texture, how much you see on it. And today I was working, Brian helped to do the whole thing as well on as an SDF to load this. And then we here get, for now, just one tile of the city of Vienna. And then we hope to have the whole city by next week, and then start doing emissions on the geo positions where people are, putting their points. And my idea in the end would be that we can see like places that people like and where they interact and places they want to change. And it's like a cool particle visualization about that. And yeah, how that could look like on site, I would say I give it back to Christoph once more.
So, hello, can you hear me?
Yep.
I might sound a little bit different than before, because I'm on a different, am I too loud or something, or is it good?
It's okay. Good.
Oh, okay, great. So due to this funding, we were able to afford this wonderful multi-touch and object recognition table. And right now it's doing nothing. So basically this map will be the base for the visualization Rosie was presenting right now. This is just right now this tiling system that I developed. So this will be later than the data sculpture, the data visualization of Vienna, due to the correlations of the movements that the visitors feel connected to, and the places they want to change, they have changed and stuff like that. And in order to also show these points like naked, we have this OpenStreetMap in here. It's fully as a full screen web renderer right now implemented. And yeah, this is right now like the test data that we have on this table. And of course, later we can always switch between these two views. This will be the city view, just Vienna. This will be the map, which will be clamped later to the view of Austria, because we're focusing on climate activism in Austria and not worldwide or Europe-wide. And so basically, where does this data then later come from? So we want the participants of this activism to camp and other people, we want them to put in their data. So either they can open a website on their smartphone, because there will be a QR code, or they can grab one of these objects, which will be placed next to the table. We somehow have to also connect them to the table, so they're not gone after 2 or 3 days. And once I put this object on the table, it lasts now for a second, but it will get shown a web renderer. So connected to the object on the table. And this web renderer can be duplicated multiple times across the table. And all of these are individually interactive. So all of them can be used. Basically, this also has now a map in the mobile interface. where I can now select a location in Vienna, or actually in the whole world. But actually, as I said, we are going to clamp this later. And we can now, I think this is really complicated right now to see, but I hope you get the idea that here I'm now marking locations in Vienna due to the question, in this place I feel comfortable. Add as many places as you like where you feel comfortable, and so on. And you just add them to this. Once you're done with it, you click next. Next question is, in this place I feel uncomfortable. So you do the same procedure and you add places. Maybe you go out of Vienna. Yeah, maybe where's Amstetten? I feel very uncomfortable there. Yeah, so add it. And so next, so on. Yeah, I will just add some test data. Add next, next, next. And in the end, you get like a list. This is not fully designed right now at the moment, by the way, but you will get a list of climate organizations that you like. You feel like you belong to them, or you kind of sympathize with them. So you can also select them. In the end, you submit. There's right now some lag. It's going to be solved, but in the end, you will be greeted with a confirmation, basically. Yeah. So you cannot see it right now. These points have been added to the map in the background, and further on, I will just remove one of these. It will then use two different objects. One is called the movement filter, and one is called the emotion filter. So basically, you can set here like which. You can already see that it's affecting the map in the background. You can deactivate different. It's going to be styled in the end, but you can deactivate different movements, like the movements that you saw also in the selection there, and you can enable and disable them, and they're being then filtered on the map. Also, these emotions that are provided through the button topics. So you can always make a many-to-many correlation between the movements and the emotions. And what we hope to gain through this project is to somehow motivate the people from the activistic camp to find out, is there collaborative potential between movements? Are different movements already working in a similar area, or are there areas where actually the perception is clashing? So one movement is telling, yeah, this area is super, and the other movement is saying, yeah, there is a lot of shit going on and stuff like that. So these are things that we want to find out through this project, and also as the whole thing is standing there for 5 weeks, we hope that it will enable discussions, maybe also some talks or presentations and stuff like that. And of course, everything will always be at the same time animated and visualized in real time on this 3D map of Vienna, which is not usable at the moment, but it will be in 2 weeks. Yes. So this is the project for now, and I will return to my place. And here I am. I have to unplug. But basically, I'm finished with the presentation, and thank you very much. Maybe you have questions.
First of all, thank you. Thank you for the presentation. I think it's interesting that you have this kind of funding to develop libraries for your own forthcoming. That is something very smart. Yeah, it sort of makes sense. I guess this is for in-company use only. But I think it's, just as feedback, I think it's a super smart move, and it makes completely sense as a, vvvv-based startup to do something like this. So is there, was it hard to describe this to the city of Vienna to get this funding, or is it the city of Vienna, or where is it coming from?
From Vienna Business Agency, Wirtschaftsagentur. Yeah, it took it took some time to think about how to formulate things totally. Yeah, it was hard. Yeah. Yes, but it worked out well in the end. And I mean, as you're asking, of course, some of these workflows and libraries there for our productions, but we also plan to release them at some point. And yeah, for example, in this project now, there are some workflows for data visualization, a multi-touch framework that has been developed. Also, we got help with the multi-browser rendering on the table from the V4 group. So that's also accessible from the help browser. And yeah, so it's nice to work on projects like these. And also thanks for Rosie for opening the network in that direction and making that possible.
Is there any more questions from the online world, Maxime?
No.
Okay.
There is no.
Then I would say maybe that's the point where we do a little break, like 15 minutes maybe, and then after this we would have Tebian. Is that all right, Tebian?
Sounds good to me.
Yeah, okay.
Enjoy.
Then it's a 15-minute break.
Thank you very much.
All right.
Präsentiert vielleicht alles.
Passt schon, ja.
Gucken, ob da was hört.
So we're back in the space. I hope online everybody else is also back on their desks. See Christoph. Cool. Tebian is also there. Great. So everybody's inside. Well then, Tebian, next is you.
Yep.
I think there's a lot of people very curious to see some insights of what some users have been seeing on social media already. It was quite impressive. Have a go.
All right. Thanks for having me. Nice to be on the show again. Okay, so just to get everyone into the same boat, I'm going to present a short sequence of slides to show you what I've done so far, and then we'll see, of course, a little bit of live catching in the demo of it. So the topic is getting all these interesting new technologies that are happening in the software space into vv and your projects. And so the first question is, of course, why is that interesting? The second question is relatively uninteresting for the user, but maybe for you is how it's done. And then you're going to learn what's available already, and we'll finish with the demo. So if you look at this graph, which is an analysis of what happened on the open source space in the past years, there is a little bit of an explosion here. And the release of ChatGPT certainly triggered a lot of hype. And in this slide, you see the amount of new repositories created in the last years in the field of AI and machine learning. Yeah, don't know about you, but I think this could be seen as some kind of a trend. And that's a very good blog post here, by the way, if you're interested in it. And the applications for these repositories are, what I think, are very interesting for creative coding and, in that sense, for vv. So a lot of them are bots, of course, chatting with users, user services, and customer service. A lot of it is coding, helping people to code. And yeah, other things, image production isn't the biggest one, but it's quite interesting as well, of course. Now, that is the reason why it's interesting and why I've started to work on it, because I felt that this trend is not going to stop in the next years, I guess. And I think everyone is interesting to use parts of it in their projects in the future, because also clients are going to request it, of course. And now the question is, how can it be done? Because most of these things are written in Python, because Python is generally used in more the science community, because it's a very easy to learn language, and it has a lot of very good tools for statistics and all the things you would need in research and science. But VV is a C# and .NET application. And now the question is, how can these two go together? And Python, luckily, is quite friendly when you want to embed it in somewhere. And there is already a project that helps to embed Python in a .NET application. And I've used that to create this node. And this node represents basically the connection point between the Python interpreter and the VV process. Currently, it's quite monolithic. I think it's not possible to have more than one Python process per process, VV process. But already with this, you can do almost anything. This is how it looks when you want to use Python in VV. So you can either just put a code string there and then execute it in this Python region, or you can load a Python file and then call methods in this Python file. So there's this core node, which is called PyInvoke. It will take a string of a name of a method in Python, and then it will adapt its inputs to the amount of inputs of this method. It's very simple. Python isn't a compiled language, it's an interpreted language, so it's all at runtime. It's kind of very friendly, and you can do a lot of it in runtime. So it's a dynamic language, it's not type safe, which also makes it kind of easy to work with, but you need to know some stuff. Yeah, so that's the core of the development. And what this enables you now, or me, is to load any Python script and call methods on it. And then in the VV process, you can either interact with the Python objects directly, or you can do the transition from the Python world into the .NET world. So there are these two options. And we are going to see that the workflow of staying in the Python world and just managing Python objects is quite interesting, and often the thing that's used more from my experience now that I've worked with it. So the first thing, of course, that I did was, and was also a bit of the motivation why I did it, was to integrate stream diffusion. Because it's the first time now, I think it was released in February or even January. It's the first time now that you can, on a consumer GPU, run image generators in a high frame rate, so that you can change inputs and interact with it, and you immediately see the results. And what these people achieved, the researchers, is very, very impressive. So you get 60 to 70 times faster image creation than what was possible before. And that's really impressive because it has two benefits. The first one is, of course, it uses a lot less energy. The whole AI space uses an insane amount of energy. So the first thing you get from this, it uses just a fraction of the energy to create it. And of course, it's much faster. So you get this interactive component to it, which makes it interesting in real time and interactive installations. The output, unfortunately, is always 512 by 512. There's currently nothing you can change about that. It's part of how Stream Diffusion works. It's a highly optimized engine for just one case. But you can see here, these images have been created with this engine. And the very interesting thing here is that Stable Diffusion usually has like 20 steps. And what steps are, that it means you start with a noisy image, and then you gradually reduce the noise until you get some image. And Stream Diffusion does this with just one step. So it's really insane. So you go from a noise input to a clear image in just one inference step. It's completely crazy. The quality isn't the highest, of course. You can see I've made the image a little bit smaller, so so you cannot really zoom in. So 512 by 512 is just what you get, and you have to live with it for now. But of course, we don't know what happens in 2 years. So so that's the first thing I'm going to demonstrate after this slides. And the second one is this new model, which just was released a few weeks ago from Meta, which is a very small model. These text-generated models, they have this this info, how many parameters they have, and that defines the size of the model. And 8 billion parameters is actually really small for a text-generative model, but the intelligence of it and what you can do with it is completely mind-blowing. And once this was released, well, there were more Llama models before that, but this one now is really a step ahead, and was just released while I was working on the library. So I was looking into getting text-generated models into the system, but when I found out how good it is and how much better it is than everything that's at this size that you can run on a computer, a consumer laptop or consumer GPU, I stopped the other things and just concentrated on this model because, yeah, it's so far ahead of the others. Now people found ways to make them even faster by so one of these if you take one of these models, it's just a bunch of numbers basically, and the precision of these numbers is usually 16-bit, and people started to notice if you reduce the bits, the models are still almost as good as the original one. And so there are two projects that run these quantized models. One is called Llama CPP. And that's very interesting because in this backend, you can decide how much of the model you want to run on the CPU and how much you want to run on the GPU. And XLlama v2 is another backend that only runs on the GPU, but mind-blowingly fast. I haven't finished that. I can, in the end, show a short demo of how fast it will be in another software that uses this EXL2 format. But this one is finished and works quite well. I'm going to show it as well. So these are the two things. So image generation with stream diffusion and Llama 3 text generation that I already implemented with the Python runtime integration. But of course, there are many more possibilities now that could be implemented in the same way. So my main goal and focus of this project is, of course, to make it easy to grab anything that gets released tomorrow in a week and make a nice package for vvv for it and use it together with other things, ideally. And yes, that's currently what I got. So I have these 3 packages plus the core package via Python. And at the moment, I gave it to a few people who joined the early access program for a fee. And what I've noticed was that the installation and the setup is still very complex. It's not easy because the stream diffusion folder in the end will be, I think, something like 20 gigabytes or so, because it needs so much stuff. And you need to get the dependencies right and all of these things. I've tried to write scripts that do that as good as possible. But still, everyone who joined the early access so far needed my help to get it to run. So just to put it in perspective, how not easy it is to get it to work. Anyway, on my computer it works. So let's have a look how it goes. So here, we have patch. Let's make the patch a little bit cleaner. And let's start it. So here's the output window where we're hopefully going to see something. Now, if you use Python, or if you used some AI project before, you usually see a lot of output in some console window. And that's why one of the first things that I did was redirect the Python console output to the vv console. So the good thing to do first is to open the console and let me arrange the windows better. That. So, and now you see here's the runtime. And then to integrate stream diffusion, I've created a script that I adapted from the existing script, added some methods to it that are easy to call and to interact in vv. And yeah, it works quite well. So stream diffusion has a few interesting things. You can choose what kind of acceleration you want. And if you have a modern GPU, like a 30 series or a 40 series, you can choose the Tensor RT acceleration. I think it also works on the older ones, but it's not as fast. And this one is the fastest you can get. Then there are different ways to do the guidance of the model. If you're a little bit into how stream diffusion works, you would know how this is, but it's all not so important. The important thing is that you can here enter whatever model is available and of course runs with stream diffusion from Hugging Face. They always have this ID called the repository ID and then the model name. So if you enter this and you press load model, if you don't have the model yet, it will start downloading the model and you will see that in the console. But I already got the model. So if I press load model now, we should see it finds it. There's a little info that there is no safety checker. So yeah, and that's it. Now the model is loaded. And you can see here, TensorRT acceleration is enabled, so we got the best speed. And now this node outputs the Python module, which is this script. So it's basically a handle to the code. And then it also outputs the image generator class, that something that I wrote in Python. And this image generator class then has methods that you can call. And the most important method, of course, is the generate image method, which gets called in here. And if we now hit generate, we should see something. Yeah. Okay. So now, if you generate images, there are several ways, of course, to influence what kind of image you see on the screen. And usually you enter some kind of text and describe what kind of image you want to see. And then the model tries to generate this kind of image. And if we go in here, we have this this process where we can get a reference to our generator. And the generator has a method that can encode text. I think now at the moment we are seeing this one, cube sculpture with red details. Often these prompts look a little bit ridiculous, but often it helps for image quality. So this text encode takes the string that you write, just human readable things, and creates basically a big vector out of it. And now that is very interesting because this vector now, you can imagine it a little bit like a point in space. The point in space where if you feed this point into the model, it will generate something that is associated with this point in space. And now you can take another vector from another prompt, flower field, and you get another vector. And now you can just, like you would do with normal 3D vectors, you can now do mathematics with them, which is very interesting. So now we can basically walk from this point to this point in this text encoding space with the slider. So if I turn the slider here, we slowly go from this cube sculpture more and more into a flower field. And now you can interpolate in different ways. If you use a lerp, it will be a little bit different. So you go in a straight line from one point to another. Then you cross maybe things you see inside of here that, yeah, that are somewhere in this space, in these two, between these 2 points. And the slurp, the spherical interpolation, will do like more a circular movement. And if these things are more outside of this text space, you will travel more on the outside of the space. So it's more abstract here because these two prompts are more abstract. Now you can do more with it, of course. You can take this vector that you get here, which is another point again in space, and then add something to it. For example, we had just the text encoding of a cat, which is also a vector. This is the point where the cat lives in this space. Now if we return this one, yeah, we see that. For whatever reason, I don't know. We go to the other prompt. Yeah. You don't know what happens, and there's probably things you will see that are not possible to get when you just type text in here, because yeah, this mathematics here will maybe yield a point in this text embedding space that isn't otherwise reachable. So yeah, that's the cube sculpture. Now cube sculpture with cat applied. You can also like just do cat plus dog. Yeah, then you have some kind of cat dog. Don't know. Or this, and then you can interpolate to a cat flower. Oh, flower field plus cat seems to be a wedding. Don't know. Yeah. If we just go there, we should see the flower field. Yeah, interesting. So maybe people who marry often get a cat or so. I don't know. So yeah, that's one interesting part. And you see the image is always moving a little bit. That is because, let's go maybe back to this prompt alone. Or maybe with the cat, it was funny. Okay. Because currently what's feeding into the system here that triggers the image generation is me at the webcam here. So, and this is basically the beginning of the denoising things where this image gets noise added, and then the diffusion algorithm does a step from this image plus noise to this image. So yeah, that's kind of cool. So you can move a little bit around and it kind of does something that resembles the input image. And it's also interesting, you can now do a lot of pre-processing here of this image. For example, if you invert it, you get something that's the other way around. And you can add contrast, remove contrast, or yeah, desaturate it, shift the hue, and it all does something, which is quite interesting. And then you get like an offset and scale, which also influences a little bit of what happens. So there's a lot of room for experimentation here in this part. And you can spend hours here. If you drive it a little bit too high, then it just gets like very close to the image, but not very interesting. And yeah, and if you go down again, you can go back to just the noise, or the noise plus the image. Yeah, so that's this thing. There's another interesting thing I'm working on right now. I just started yesterday with it, which is you can get the latent space from this engine and feed it back in. So you don't have to input an image. You can also input directly the latent space. And if you do that, currently it's some kind of feedback. It's not finished yet, but you see this is kind of the internal representation of what the model likes to work with. This is this chair. And then you can, I don't know, scale it a little bit, and then you just wander off somewhere. Add more noise, less noise. Yeah. The interesting thing is, if you're in latent space, the image is only 64 by 64 images, and it's super performant. It's much faster than if you use the image input, because the image first needs to be converted from RGB space into this latent space. Yeah, so a lot of interesting things where you can experiment. And yeah, that's where it's at the moment. So if you have some questions or something, let me know. Otherwise, I would go to the next demo.
So this is running on a stationary computer right now, on a 4090.
Sorry, I didn't hear it because my fan is a bit loud. So let's stop the generate.
So this is running on your laptop or on a stationary computer with a 4090?
Yeah, it's my laptop, but my laptop has a laptop 4090.
Okay.
So that is a bit like a 4070 desktop. And you get, so with Zoom currently it's like 30 or 40 FPS, but without Zoom it's about 40 to 45 FPS on my laptop. And on a good desktop card, you easily get 60 to 80 FPS.
It's impressive.
Yeah.
Yeah, yeah, it's impressive because of the speed and also that it's possible to get like into these weird multi-dimensional spaces and just do some funny math there, and you get interesting results. Speaking of results, let's close this. There was already a public show that was running it by Konstantinos Nisidis from Greek Athens. He was the first one who said, okay, I have this show, I need to have it, I need to join, I don't care about how difficult the setup is, I'm going to use it. And he basically got in like 5 or 6 days, got it running. He created some kind of little prompt UI where you can select prompts that work well, and then he has kind of this input image, and then he uses this to do the live show. So here on the live show, for a funny prompt, it's running in The Hague in Netherlands on some festival, and together with they synchronized it with a laser show, and yeah, quite interesting what you can do with it already. Okay, so the second demo. This little chat bot where you can talk with the Llama 3 model, which is also available on Hugging Face. So you just need to enter some model from Hugging Face. And if you haven't downloaded the model yet, it will download it. So it's the same way as with Stream Diffusion. Then you click Load Model, just loads it. And yeah, then this is the part where you can specify which model you want. You can enter the context length. So the context length means how much memory a chat or a model can have in a chat. So the way these chats that if you use, for example, ChatGPT, the way these chats are handled is that the whole history of the chat, so everything that's was input and output before, gets always fed into the model when you call the inference. It's called inference. And the context length is how many possible tokens, and the token is usually a word or a dot or exclamation mark or something. So you can have 8,000 tokens in Llama 3, so about 8,000 words, which isn't that much because the model isn't that big. but still, it's quite interesting for simple chats and everything. It's very impressive. So the first thing you need to do is tell the system what it should be. So currently it's set to 1, so you're a helpful assistant and only give short answers. And you say, okay, we set the system role. And then the first message in the chat is, okay, the role system. And that's basically the instruction. That's why these models are called instruct. So now you set the instruction. And then you can send some text. Just say hi. And send it. And we see I've also implemented some background threading here. You get the full FPS of vvvv. And the model will stream the text in the background. How can I help you today? Let's say, what is vvvv? Oh, open source game engine. It's interesting. Oh, and it's a short answer. Okay. Close enough.
Well.
Let's see. What? So yeah, let's maybe change the instruction to something that David was asking me to do. Is quite interesting. You are an interviewer and you only ask questions. That's quite interesting. So we can set that. So if you set it, you see only the first message is changing, and all of what happened before gets fed back in. But you can also reset the chat, and then you have only this message. Right. So now it starts to interview me, and the interesting thing is it really asks interesting questions. Also, what do you like to do in your freedom? Okay, that's not the most interesting thing, but let's say I like to
Maxime, yeah, is this? Yeah, so you can zoom in with control mouse wheel into the screen now.
Control mouse wheel? What? Sorry, now my bell rang. I quickly need to go to the door. Very sorry. I'm back in a second.
What is Tibia doing? What?
He just left.
He just left for what?
Yeah.
Thanks. Didn't know.
That's the interviewer rang.
Follow the mouse. There is an option.
Okay.
Then we don't have to somewhere.
Is it big enough or?
So we need an interlude. Can we have some modular interlude?
It's not working, unfortunately. The cable is not suited.
What did he say? When is he back? What's happening?
It's gone.
He's gone. Anyway, it's quite impressive.
Okay, so I'm back.
Yoo-hoo!
Yeah. Let's try a 5-year-old kid that has no clue about the world, but is an expert in quantum physics. And what are you doing? Some particle collapse, yeah. Just kidding. Probably with my toy cars and think about many worlds' interpretation of quantum mechanics. Did you hear why Schrödinger's cat went to therapy? Because it was in a state of paradoxity. Wow. Quite cool. And it's all running on my card. If we have a look here at the task manager, it's about 12 gigabytes on the VRAM. And if you use a smaller quantization, so here we have quantized to 8 bits, but you also get like 6-bit, 5-bit, 4-bit, and so on. Then you can even run it on smaller cards. Yeah, so I think that's it for the demos. Oh, one last thing here, you can tell the backend how many layers you want to run on the CPU or the GPU, which is handy if you don't have a big GPU or you have a huge model. You can also load bigger models. And then it gets distributed between GPU and the RAM. And yeah. Okay, that's it.
Yeah, thank you, Tebian. Impressive. I think an obvious question for everybody is how your roadmap looks like and how, yeah, like what's your timing with this and what's the release goal for a first version and how do you plan to get users on this?
Yeah, good question. I think the first thing is that I cannot spend that much time at the moment on it. So because yeah, I have normal jobs at daytime, and so I can only spend a few hours per day on it. It's quite exciting, so I'm doing it, and I'm also sacrificing a little bit of my private and social life for it. And that is also the reason why currently, if you want to join the early access, you have to pay something for it to maybe free up for me 1 or 2 days per week to work on it. Because I think the potential is very big with this, and I'd like to work more full days on it. And I think I also will not release it ever for free or open source, because yeah, basically I'm a software developer. It's how I make money, and yeah, I want to make money by selling software. So yeah, so if you want to use it, you have to expect to pay something. But after the first release, it will be probably there will be a professional license with the same price as of now, but also like a home use hobbyist private license that will be very affordable. Don't know how much yet. I have no clue about it. I'm not a good business person, but this is how I plan it. Ideally, what I also like to do, what I always wanted to do, is to do pricing based on cost of living in your area. Because when I tell people from other countries how much I'm currently expect to pay them to join the early access, that is for some people a huge amount, and for other people it's not that much. So I'm thinking about some kind of way to.
I can completely agree on this. We also experienced this with the Node Institute
Yeah.
basically every day, and we're also thinking about adjusting the model there into the same direction.
Yeah, let me know if you find some ways to do this or to automate this in some way. Yeah.
Well, maybe you're the better automator here. Ask it.
Yeah, we can ask it. Yeah, but it's the kid that will just make jokes about quantum physics. And the first release, I don't know yet. I think it's still a long way because the setup is so complicated. And I have to look into things like Docker or Conda that will automatically create some weird virtual machines on your computer, or just pack everything and then you get a download of 20 gigabytes. I don't know yet. And also what's also not yet really solved is how to export You can now, of course, with vvv create an executable of dispatch, but then you have to copy all Python things next to it in the same way, which is also not really practical. So it is a big thing to think about it, how you can create an executables and binaries from it. And yeah, I think public release more like 2 or 3 months, to be honest, depending on how much time I can spend on it. And yeah, if you really have a project that has funding and you want to use it right now, just contact me on social media or write me an email. I'm happy to get you into the program and help you setting it up for the project. You can reach me in the vvv forums. Here I've created a forum thread where I also update the latest updates that happens, and here are links to my social media where you can contact me.
Thank you.
A few questions, Debian.
Yes.
Asking like if there are going to be a discount for students somehow.
Yes, absolutely. I think students and educational discounts, absolutely, because it's the same thing with the different living costs in the world. As a student, you cannot, you don't have professional clients that pay you like a few €1,000 per project. And yeah, of course, I have to think about it.
And coming back to stream diffusion, Q is asking if it's XR stable diffusion model already available, or is it still 1.5?
Yes, SDXL is available, but there is no Tensor RT acceleration yet available, which makes it a bit slower. So on my laptop, it was about 45 with SD Turbo and about 18 FPS with SDXL Turbo. So you lose more than 50% of speed if you use SDXL, unfortunately. But yeah, the output is much better and it looks much better. But I've also seen some kind of development in the stream diffusion repository in the last few days about something called Hyper SD, something that just got released a few days ago. And that also sounded interesting, but it's also based on Stable Diffusion 1.5, I think. Yeah, but you can run Stable Diffusion XL with much better quality, but slower. But if you have a good graphics card, it will be fine, I guess.
Okay, and one last question. Hayden is asking, are you considering a LangChain implementation on top of this?
What kind of LangChain?
Yes.
Yes, LangChain, yeah, I've looked at it. Currently, I only implemented these low-level backends, Llama CPP and XLlama, because they give you direct access to everything. But LangChain is, of course, totally possible. I've looked at it. They have a lot of backends also, so it's a bit more of a high-level chat interface. And yeah, totally. That sounds great.
Good. Otherwise, everyone is cheering.
Yeah, I think we also need to wrap this in order to not go too late. Yeah, everything can happen on the forum, in the chats, and in direct messages. So thank you, Tebian, for joining this exciting new possibility with us. Huh? Thank you. So up next is then Hannes Schmidt. Danke, Tebian. Kopffarben. Presenting some new nerdism.
The mic and the...
Just where's the mic?
Ah, the mic.
Should have the mic.
The webcam is there.
Yeah.
That's the camera.
This is the camera.
That's the camera?
Is the mic.
No, it's this one. Sorry.
It should be...
That's fine. That's fine.
You can hear me?
Just put it on the laptop. Yeah, it's 1 minute time.
Okay, so everybody hear me? Okay. So I will show some IMGUI stuff and IMGUI multi-viewport channeling. But let's is it small? Share my screen. Yes. Let's start. Yeah, and it will be a part of the standard libs. It is pull request is still out there. I need to fix something, but yeah, we're on the way. Yeah, I can hit.
What is it?
What is it? It's window handling, docking, and multi-viewports. It's called an IMGUI, but I think it's the wrong name for. It's you can pull
It's
out.
nothing to do with the viewports.
Yeah, it has nothing to do with the 3D viewports. It's just a window manager for Strike windows and Steer windows and IMGUI windows and all combination of this. Oh, so let's go to IMGUI Strike and here and the IMGUI Strike windows. At the end, this is just an IMGUI region called IMGUI window, and you see update really slow, and you can see the this is really bad. Yeah, and here you have this is just an like a normal renderer. But it's on the screen it's really bad. Yeah, and here this is at the end. It's just some. This is slow.
It's not on your screen, it's not slow.
On my screen is not slow. On my screen feels like yeah, it feels good.
Just look at your screen.
But I'm looking there and it's really bad. But maybe I show the main feature. The main feature is something like this. You can just pull out your window, your IMGUI windows out of the IMGUI renderer. All windows have what you expect. The curve meter, all the stuff that maybe you don't see. Yeah, and here we have a render window and input. It's on my screen. It's not this laggy. Yeah, you can put it back. The same. So this was an iRenderer window. This is a Skia window. You see it handled correct mouse inputs. You can put it there back, and you see it makes always a new window popping up in the taskbar. And gun. And if you like have it more fancy, you can enable docking. Now you have a docking space and can dock your windows how you expect. Bring it out. Yeah, maybe I stream in 4K. The 4K is maybe too crazy. Maybe that's the problem. Yeah, that's maybe we should switch to Full HD.
Let's see if it can handle it.
Yeah, I think vvvv it's still running somehow. Oh yeah, my windows are here. Nice, it's still working. This them out. Yeah. Yeah, and you can have all you can render with vvvv. You can handle it. So the stride scene, stride renderer, and skier. I think it's more or less, and ImGUI, of course. So at the end, it's an ImGUI Windows manager. And if it's, but that is the bug in ImGUI, if you can save the layout and read it back, but it's now, for now, not working. But it should work. You can just save your editor layouts to one file. Yes, that's it.
Can you dive into the subpatches here on the left, like skier branching?
Yeah, skier branching, it looks really, it's just the skier ImGUI window with a console, mouse theme. So that is just the help patch. All of
copy
this,
and paste of the help.
Yeah, it's a copy of paste of the help patch inside
inside that region.
Inside the yeah. And yeah, we have this. I have so this package spring, the ImGUI region, the ImGUI window region. Then I have the layer widget, which helps this help you to render a skier layer. Then I have the scene widget that here, now it's outside the scene, but it can always be inside. It's a scene widget with all the stuff you have normally in the root window or in the window. There you have the clear and all the stuff you have here, the post effects and so on. And we have the render window, the render widget, scene widget, render widget, layer widget.
And what's that little node on top of that? And read it.
Which
Get
node?
content regional.
That should just make this full screen in the window. That makes just, you can, in the render widget, you can say which size it should have. And so this is I just asked how much space I have for the window and make it full screen. More or less. The render widget is full screen, but it can be just a part of something. And it handles always the now okay. The screen size change fuck up my input handling.
So my question is there a higher goal of this development that is synced with the vvvv group's development for the overall environment? Or is this your personal
This is just my personal research
for
my next project. I want to have a nice editor.
Okay.
It's not a lot of Windows with just that window management system, and yeah, maybe you need to ask this guy.
Well, it's up to you to answer this question, because it's obviously something that many users are, wishing for since a very long time, I guess, and now we can see this already happening, like in its own style of development, and it's a question that is natively there. So if you can answer that partly, it would be a nice.
I would say that this whole topic is an incredibly complex topic that's hard to just answer meaningfully and in a way that you would say, ah, thanks, I understand, and that's nice, I will have it tomorrow. So you will not have such an answer, but it's amazing to see this research and see how this goes, and we can learn from that. I would put it like that at this point. For us, it's interesting to see this. It's already possible to do this at this point. Someone else can even do it, we don't have to do it. But when we are thinking about how to apply this to the whole ecosystem of vvvv, we are not there yet. We're just still exploring different options. This might be one of them, but it might not be one of them. It might not be the one. Which doesn't mean that this, at this point, in this place, makes sense. No?
Application.
Exactly. No, it's already an amazing development, and we will learn from it. But if we apply it finally for the whole thing, we're just not.
Yeah, that was the question. Thanks for the answer. Is there any more questions? Online? Yeah. I don't have a further question. I can see myself using this for custom applications.
Yeah.
Obviously.
I have maybe one. Do you see, or maybe all of you, do you see a way to unify the different types of windows we nowadays have in vvvv? Like, for example, we now have a steer window, somehow a render window, a scene window.
See, that's why I said it's a immensely complex topic.
But I'm trying to not cover the whole topic, but only this single topic of we have like 3 different types of windows. Wouldn't it be nice for like having a first experiment, just having a window where you can connect? Maybe you have just a skier input, a stride input, and a render input. So at least that is, I could patch that if I could access the code. Of course, it would be kind of easy, I would say. But the chance to simplify the choice of windows is great all the way. Already, it would help like all the beginners, all the places, interchange all these things.
That's the whole point.
Yes.
This is something like this. You have this in-GUI window where you can put in everything.
Yeah. And also have like your in-GUI also living in that window natively, like having a control interface and menu for your app where you have like enable the perf meter could just be like, oh, debug perf meter, click. So
yeah, you can run a Kairos or whatever inside one of those windows, so whenever you want. So,
I find it quite interesting because silently I ported Automator to in-GUI, so it would be a prime example to make a docker builder.
So as a side question, what is vvvv or Gamma using for rendering windows right now?
I don't know.
Is it portable to Mac?
No. No, that's like we have to work on this, and we are on the side always exploring, testing different options and following all the things, but we are just not at this point yet. We know it's the most important big next step, but there are.
This application, this is maybe portable. Because it's just with SDL and it should somehow possible to port. Because I just use SDL inputs as input.
Okay, I would say we shouldn't go into a deeper discussion at that very moment. I mean, we can save it for later discussions and also online and in the chats and whatnot. Thank you. And then we have
I would love to, but the work cable is not working.
Ah, okay. So,
but I can give a analog
then representation. Should we just turn this camera to your face? Can we see that? Okay, good. Yeah. Well, just.
Yeah, I mean, I can show it silently. So. Hi, my name is Andreas, aka Mindfuck on the forum. I came to vvvv by also Next-VSP in NATO, and then made a switch like 20 years ago. Basically, made the switch over to vvvv for visual purposes. Now I'm back at audio since Corona happened. I didn't do audio for a long while, but then since Corona happened, I also get infected with the Ureg virus, I call it, because it's quite common nowadays that people use very archaic systems like that in their productions. This is called Ureg system, so it's a type of a synthesizer, analog synthesizer, where basically every signal is available here on this little like output ports. The signals are in voltage, so basically you have like voltage levels here from minus 12 volt to plus 12 volt. And you have like different types of signals, but basically they're just like one signal. It's like in volt. You have audio signals. Audio signals mean you have like very high frequency signals, and then you have like control signals, CV signals. They're mostly below, I don't know, 10 hertz or something like that. There are other types of modular synthesis, like Buchla, for example, where like there's a very distinction between audio signals and control voltage signals. In your format, that's not the case. So you can basically patch everything to everything. With one exception, you basically patch an output to an input and not an output to an output. You can do, but there are modules which can damage the system. So really pity, I would really like to show this system here today because it's like the analog type of patching. So my love of patching is not only for VV kind of cables, but also in like music analog way. It's a really fun hobby, but also an expensive. Yeah.
Wow.
I mean, I can show here to the people around how it sounds, but unfortunately, the cables we have here are not working to show it on stream.
Yeah. Well, maybe we have to make sure that we have somehow an emulator on the videos. Want to publish this?
Yeah. Yeah. So,
is there any questions about that without hearing anything?
I can show the people in the room.
What are the different modules there?
Okay, so
there are many microphones.
This node here, I can show how the module looks when I. So these are like single modules, as you can see. They're mounted here by a little screw. So I can get one out for you to show how a module looks like. So modules can be analog, meaning discrete analog circuits, like this one here, for example. But there are also like digital modules, like this one over here, that basically have an AD/DA converter, like converting the analog signal to a digital one and then back. The first module here is called a function generator, which is exactly doing what the name says. It's generating a function, basically like the AD function in attack decay in vvvv. It can also do things like slew. Slewing means basically damping. You put in, for example, a gate, and then it doesn't go like instantaneously from gate means you put in voltage above a certain threshold, for example, 2 volt, or 10 volt as a gate, and then you put like, you have 0 volt, and then you put in 10 volt, and then you have like a high state. And the slew would basically slew the kind of travel going from 10 to the 0 volt in kind of a time domain. You can set it here in the sliders. The next one is a very kind of special module. It's a digital counter, shift register, can do all kind of weird things. You can like access the single bits here, but you get also a CV signal, meaning like adding all the bits together and then make a step signal here. This here is oscillator, but also can function as an envelope low frequency oscillator with 6 related oscillations, and you can set the ratio between the oscillations here with a knob that says, for example, if you have it in the center like that here, then all of them have the same frequency, but then if you turn it to one side or the other, then they slow up, they speed up or slow down depending on how you set it. Here you can set the frequency, the overall frequency. You can set the shape going from sinus shape to a triangle shape, for example. So classic wave shaper, which you had in back in the days in vvvv. This here is a filter. Filter means in the audio domain, it filters depending on what type of filter you have. You have, for example, a signal that has very many overtones, and then with a filter you can filter out the overtones. And a signal with many overtones would be, for example, a saw, and you can filter a saw to a sine with a low-pass filter, it's called. But I mostly use it for as a voice, meaning what you can do with filters, you can also ping them, give them very short triggers, and then they make a nice sine tone. And then when you modulate them, it can get really wild. It's kind of a mixer logic module. And
are you doing live shows with it?
Not really. It's mostly for my own satisfaction.
Do you have any recording or this can recreate
yeah, I have recordings, but nothing I want to show here.
Okay.
I have like my whole hard disk full of recordings. Yeah,
great.
So this is just a small system. There are people that have like a whole wall full of modules. I prefer small systems. Yeah. So
that is cool.
It's a lot of fun. It's a bit like patching in vvvv, but in the audio domain and analog. There are like software emulations as well. VCV is one of them, which looks very much like the real thing, but with like virtual cables. I also still use Macs. Also use VCV, but it's a different thing to touch.
The worst thing about modular is that there are no spreads.
Yeah, they just got introduced.
They did?
There's a company called Tip Top Audio, and they just introduced polyphonic signals to your rack, but I don't know. It's very new, and I'm not sure if it's the best thing to have, because it obviously breaks with the standard. But yeah, spreads would be nice. My kind of spread is basically this module here, because it's like 6 interrelated oscillations, and it's very much like a spread thing, except that you have like patch like cables for every voice.
Did you ever integrate them with some visual software or some other, or software in general at all? Like, I could imagine having a software controlling via a microcontroller, for example, different input, output, some things you want to automate on
yes, by using Macs, and you can also use like audio signals that you get out of the computer to control things in here. So Max MSP and Max for Live, Everyone Live, like integrate the software into the hardware and vice versa. Yeah, I mean, I work in like basically like everybody else here, I guess, in doing visual things. I do generative graphics to my sound, but it's more for entertaining myself. So
maybe the other way around is more interesting to sense. I had this talk with a colleague of mine using a modular synthesizer, making some sound, and then using some control voltages to trigger visuals, because then you're really connected to the sound, because you're connected to the signal that triggers the sound.
Yeah.
Way, and then you can measure the voltage. The voltage is bigger, maybe that particular sound is louder, and then that visual also is louder in a visual sense.
Yeah, I mean, the classic would be to use FFT for that.
But FFT is a workaround, and that's a way where you can access the direct signal. That's the interesting part.
I mean, some things, especially in the time domain, probably need some digital DSP processing. If you're in the analog world, what you could measure is, for example, the loudness or threshold, or things going over certain amount and then trigger stuff. There are like envelope followers and all kind of modules. But as soon as you want to use the like time domain, do an analysis over the time domain, you have to go to whatever, for example, onset detection. DSP process where you can make a calculation what sounds basically are like over a certain amount of time, where when to set a trigger when one sound starts and it ends. I mean, you can do a lot, obviously. You can combine it with Max, with VV, with whatever. Possibilities are endless. But I guess I'm also using this stuff because possibilities are kind of reduced. I mean, I could make every possible sound also on the computer, but I decided to go like reducing my options.
Sounds like a playful workshop at the conference.
Yeah, that's true. Yeah. Well, thank you very much. I think we'll wrap it here. Thank you for those who were online with us. Sune, Tebian, Rosi, Christoph, I don't know who else. Thank you for those who were watching or will be watching this, and yeah, hope to see you soon. Thank you.
Hier auf dem Kopfhörer.